Everybody, welcome back. This is Chem 300 and we're continuing chapter 12 in this section with talking about the phase changes of melting, freezing, and sublimation. So our goals in this section are to define melting, freezing, and sublimation. So let's talk about these phase changes. We'll start with melting and freezing. These are phase changes between solids and liquids. So the part of the phase change diagram we're looking at here, talking about changes between solids and liquids, is down here. First, we'll talk about is freezing. Freezing is the process in which a liquid is converted to a solid, and when this happens, heat is released. And then melting is the opposite. Melting is the process in which a solid is converted into a liquid, and heat is absorbed during this process. And if we think about what solids and liquids are at the molecular level, this makes sense. Solids, the particles, remember, are stuck close together in fixed positions with very little movement. They can kind of vibrate in place, and that's about it. And versus liquids, the substances can kind of slide and move over each other, but they're still in contact. And so solids are very dominated by these cohesive, attractive forces, pulling the molecules tightly together and holding them in place. Versus liquids, they still have a lot of cohesive or intermolecular forces to hold the molecules close, so they're touching, but they're able to move around each other in a liquid, whereas in a solid, they're fixed in place. And so there's a difference in the amount of kinetic energy in these. Solids have less kinetic energy than liquids because the particles are kind of fixed in place, and kinetic energy is associated with the energy of motion. And so when you go from a liquid with a kind of a moderate amount of kinetic energy to a solid, you're decreasing the amount of energy there. And so that energy difference is released as heat. So when you freeze something, it's going to give off a little bit of heat. And the opposite is true when you go from a solid to a liquid. You're going from a low kinetic energy state to a higher kinetic energy state. There's more movement of the molecules in a liquid. And so to overcome the cohesive forces that are holding the solid together, this needs to absorb some energy, to have enough energy to kind of break out of those cohesive forces to overcome that potential energy, the cohesion that's holding those particles together. And so you typically have to heat up a solid to get it to convert it to a liquid to add kinetic energy to the system. So the freezing point and melting point are the temperatures at which this phase change happens. So the freezing point is the temperature at which a liquid changes phases into a solid. And the melting point is the temperature at which a solid changes phases back into a liquid. And for the same substance, say pure water, like shown here in the image, the melting point of the solid is the same temperature as the freezing point of a liquid. So water melts at 0 degrees Celsius and it freezes at 0 degrees Celsius. Our last type of phase change to talk about is the phase change between a solid and a gas. Just fix that. This is when a solid can directly go to a gas. And when a solid directly phase changes to a gas without first converting to a liquid, that's called sublimation. And the opposite phase change, when a gas directly converts to a solid without turning into a liquid in between, that's called deposition. So deposition is the process in which a gas is converted directly to a solid. And during this process, heat is released by the substance. And we can relate that to the kinetic energy and the movement of the particles. Gases have really high kinetic energy, solids have low kinetic energy. And so there's an energy difference here, and that energy has to go somewhere. First law of thermodynamics is that energy can't be created or destroyed, it can just change forms. So if we're starting with a lot of kinetic energy here, going to a lower energy state here, this substance has to release that energy, and it typically does it by releasing some heat. Going in the opposite direction from a solid to a gas, we need to put energy in the system to get those molecules moving and separating into the gas phase. And so that's going to take energy, takes or absorbs energy. So we can think of that as like we have to heat it up. So on the next slide, we've got an example. A video showing this phase change. It's one that we don't see as often, just kind of in everyday life. One example that you may be familiar with is carbon dioxide. Solid carbon dioxide is known as dry ice. So if you purchase dry ice at the grocery store, and you can get it at most grocery stores nowadays, they usually sell it up front by the regular ice, but it costs a little bit more, and one of the clerks will have to get it for you. But it's a solid. It looks similar to regular ice. It's a little bit more white looking, but it's made out of solid CO2. And solid CO2 at about room temperature will sublimate into the gas form of CO2, carbon dioxide gas. So it's called dry ice because there's no liquid left behind when this ice melts. It's something that people use camping a lot, like to keep their coolers cold for long periods of time, because it doesn't leave behind any like liquid, soupy mess in the bottom of your cooler. And CO2, when it's solid, freezes at a very low temperature, so it provides a lot of cooling for a longer period of time than ice made from water. In this video, we're going to see sublimation and deposition of iodine. Iodine vapor and crystals will go back and forth between the solid and the gas phase. So let's check this out.
This is elemental iodine. It's a dark, black bluish solid at room temperature. Iodine is the heaviest of the stable halogens. When we heat up the iodine, it's going to turn directly from a solid into a gas. The iodine vapor has a beautiful purplish color. This process is called sublimation, turning directly from a solid to a gas. Now we place a cold flask over top of the vapor. The warm vapor will cool off on the cold glass, and the gas will turn directly into a solid. This process is called deposition. In this case, we're seeing the deposition of iodine onto the cold glass surface, where we would say that iodine is depositing onto the cold glass. We can't do this experiment in our science classroom because the iodine gas would be harmful to us.
Okay, so there was a nice example of sublimation and deposition in the same system, iodine gas converting directly to the solid to form those crystals. It formed a solid when it cooled off. The energy went down by cooling it off to form those solid crystals. And then if those crystals were warmed up again, they could be converted directly back into the gas. So again, just like we saw with evaporation and condensation, the same thing holds true for melting and freezing and deposition and sublimation. The stronger the intermolecular forces, the more energy it's going to take to overcome the cohesive forces that are attracting particles of the substance together. So again, substances with stronger intermolecular forces like hydrogen bonding and dipole-dipole are typically going to have higher melting and boiling points. It's going to take more energy to get them to convert to a phase that's dominated by kinetic energy and motion. Okay, that covers melting, freezing, deposition, and sublimation. We'll next time talk about types of crystalline solids. I'll see you then. Thanks, everybody.